Hi everyone, this is Ms. Tom with another video on exponential functions. Today we're going to be analyzing how do you go from 2 points to an exponential equation. So let's talk about it. Here we go. So first of all, let's go over a couple of vocabulary here. We know that exponential equations are y is equal to a times b to the x power, where a represents the y-intercept and b represents the multiplier. Now it says write the equation of an exponential function with an asymptote with y is equal to 0. And I know what you're thinking. What's an asymptote? An asymptote is a fancy way of saying it's never going to cross that. So if our asymptote, I'm going to do this in a highlighter color, if it'll let me, come on, go. Okay, are you going to let me? Yeah, there we go. If we have an asymptote of y equals 0, then we know that no matter what, the curve is never going to cross it. So that curve will never cross it. This is an increasing exponential function because it goes from 0.5 to 4, 1,280. It's going up and it stays there. So we're going to draw our line, or our curve in this case. We're going to draw a curve. Looks like this. Notice how it does not cross y equals 0, and that's what asymptote means. It will never cross it. It will approach it, but never cross it. All right, next thing is we're going to notice that it says 0.5 is, oh my gosh, 0.5, that's important information. That, I'm going to do that in verde, green, that is our y-intercept. So we know that our a value is our y-intercept, so we're going to call this a is 5. The next thing we're going to do is we're going to notice they give us a point, another point on the line. So we're going to call this 4, 1,280. So now that we have the y-intercept and a point on the curve, we actually have everything we need to solve this problem, where x is equal to 4 and y is equal to 1,280. Since we know that, we just said y was equal to 1,280, right? So we're going to use the general equation and write 1,280 is equal to, we have our a value being 5, and then we have our b value, we don't actually know, so we're going to leave it as a variable, and we're going to write down our x value, which was 4. Now, we're trying to solve for a multiplier because that's the information we don't know. So what we're going to do is we're going to go ahead and isolate the variable. How do you isolate the variable? Well, you're going to divide. So in this case, we're actually going to divide by 5 to both sides. Why are dividing by 5 to both sides is because that will isolate the variable so that we now have a giant one, this cancels out, and we've got b to the 4th is equal to 1,280 divided by 5. I'm going to go ahead and pop that into my calculator. 1,280, clear that out, divided by 5, and we've got 256. So we say our answer is 256. Now, we have b to the 4th is equal to 256. A common mistake is for some people to think, oh, you're going to divide by 4 and then there's your answer. However, that's incorrect because b to the 4th power is talking about some number times itself 4 times. So how do you figure that out? Well, the opposite of a exponential is actually a square root. You always want to do the opposite of something to cancel out, also known as the inverse. So we're going to go ahead and do, instead of dividing by 4, we're actually going to be doing the square root. But it's not just any ordinary square root. Because it's to the 4th power, we need it to be the 4th root. The 4th root of both values. Because what you do to one side, you have to do to the other. So we're going to actually get b is equal to. Now you can try to figure out some number times itself 4 times is equal to 256. Or you can click on this link right here that I've linked on the file, where it says 256. How do you find that? Well, you're going to be taking the 256. I found this root calculator online where you can scroll down to general root. You're going to put 4 right here, and then 256 is going to be your value in the middle. Then you're going to say calculate. What's that equal to? Oh, it's equal to 4. So we know 4 times 4 times 4 times 4 is equal to 256. So we're going to say b value is equal to 256 cubed, or put to the 4th root, and that's equal to 4. All right, so we actually have everything we need to solve and find the general equation for the exponential, and that is y is equal to our a value which is here, 5, our b value which we found earlier, here, 4, and we're going to raise it to the x power. If you want to leave it as a generalized equation, here it is. That means that this equation will work for any point on the curve. All right, nice work. We're going to move on to the next one. All right, so here we go. We've got another example. I want you to pause the video. Pause the video if you think you can try it out on your own. If you're feeling like I can't, okay, keep going, but pause it. See, maybe you can get this one by yourself. Okay, so welcome back if you paused it. We're going to go ahead and go over now another exponential function given 2 points. We're lucky they gave us the y-intercept again. That's information we know. So the a value is going to be 4. Why is that? Because reminder, a value is the y-intercept. They also gave us another point on the graph, which is 3, 500. So we've got that as well. So now what we're going to do is, again, label. We're going to use our label maker. We know x is 3 and y is 500. So once again, we're going to set it up. We know the y is 500. So we're going to say 500 is equal to. Again, why do I know this? I'm using this exponential equation. Okay? Is equal to a. It tells me a is next. So I put a's next, which is 4. Then we're going to go, okay, I don't know what b is, so I'm leaving it as a variable, but we do know that x value is 3. How do we know that? Because it's here. All I'm doing is using this point to substitute. So we put 3 there. Now we're going to go ahead and slice it and see what we noticed. Well, we want to isolate the variable. We want to get b all on its own. So what we're going to do is we're going to divide this by 4. Divide this by 4 because we're isolating it. Then we figure out, okay, 500 divided by 4, that's going to be 125 is equal to b to the 3rd power. Now we can go ahead and check that if you'd like. We can go 500 divided by 4. That's 125. Good. Then we're going to see, okay, we've got b to the 3rd. In the last example, we took the 4th root. Are we going to take the 4th root in this case? No. This time, we're noticing there's a 3 there, and we're actually going to take the 3rd root. If there was a square there, we would take the square root. If there was a 5, we'd take the 5th root. So you're basically taking the root based on the exponent. This case is a 3, so we're taking the 3rd root. Okay. Once again, you want to calculate what that is, or some of you might be able to figure it out. Click on this link right here. It will lead you to the root calculator. We calculated this last time, but this time we're taking the 3rd root of 125. So I'm just going to clear this out. And then we notice that is 5. Oh, that makes sense. 5 times 5 times 5 is 125. Could have probably estimated that. So then now what we're going to do is we're going to say, okay, b is equal to 5. Alrighty, wow, we've got everything we need. So we write it down. We go y is equal to a. What's our a value? Our a value is 4. So we write 4. What's our b value? Our b value is 5. So we write down, we've got 5. And then we raise that to the x power. And voila, we've got our generalized equation for this specific curve. All right, so now what do we want to do in this case? Now we've got an exponential curve, and we've got to figure out how to go from a curve to a table to equation. This is our main goal for this lesson. Can you do all of this? If you can, you really understand exponentials. So let's go ahead and analyze this situation. It's asking us to come up with a situation where as the years pass on, the numbers lower. So, you know, we're kind of going through this like crisis right now. What I'm hoping is that as the years go on, the less and less people get affected, right? Or so, you know, with more years, less people get infected by the disease, right? So you can write something like that. You can just go ahead and say, as the years pass, less are affected by the disease. Okay. Sorry about my handwriting, guys. It's a little bit hard to write with the stylus here. It's a little bit easier to write numbers. But anyway, let's go ahead and talk about what we know here. Okay, so looking at our graph, we have our y-intercept. And I'm going to go ahead and highlight our y-intercept. Remember, this is our y-axis, right? Let's try that again. There we go. Our y-axis, and we got to figure out what our y-intercept is. Our y-intercept is going to be this point right here where it crosses the y-axis, which is there. And that point is 1,000 or 16,000. So we're going to write that. Then we're going to figure out, okay, 1 has how many? 1 has 14,000. I actually wrote this in the wrong place. It should be up here. Okay, so then it should be 14,000, which is here. And then we're going to talk about what we notice. Well, what do we notice? Well, first of all, we know this is exponential because it is curving. But how do you figure out what the multiplier is? How do you figure out what happens here to here? So in 1 year, we notice that the growth goes from 16,000 to 14,000. So how do you figure out what you're multiplying by to get there? Well, we take the new value, 14,000, and we divide it by 16,000, and we end up getting 0.875. So let's check that. 0.875. Now keep in mind, if you're wondering like, why isn't it 16,000 divided by 1,400? You always want to take the new value and put it over the original value. Okay, so the new goes over the original because you're trying to see how does this occur. And so, you know, if you're not sure, go ahead and just check it. Is 16,000 times 0.875 equal to 14,000? It is. Versus if you did the other way and you did this, which is a common mistake, I see this all the time. Oh, it's 1.14. Okay, if I multiply 16,000 times 1.14, you're not going to get 1,400. So you know that multiplying by 875 thousandths will get you the answer. Okay, so that means what we're going to do is for the next one, we're going to go ahead and multiply by that same amount. And then just keep multiplying by that same amount. So we're going to take that 14,000 times the 0.875. We get 12,250. Okay. And then we're going to go ahead and take that and again multiply it by another multiplier. We've got 10,718 and 75 hundredths. Okay. 10,718 and 75 hundredths. And then how do we go backwards? How do we figure out, well, what number times 0.875 will be 1,600, right? So what we're going to do is we're going to go ahead and go, okay, 1600 divided by 0.875. We're going to get 18,600 or 18,285. Okay, so 18,285. Once again, if you're like, I don't know, did I actually get that right? Go ahead and multiply it by the multiplier, 875. So 18,285 times the multiplier, which was 875. Okay, it's about 1600, so you know you're correct. All right, so we're ready for the equation. What is the equation? The equation is going to be y is equal to, what is our y-intercept? Y-intercept is 16,000, so we're going to write 16,000 times our b value. Our b value was, in this case, and I'm going to write that again because that was tough for me. There we go. 0.875, and we're going to raise that to the x power. And voila, we've got our equation ready to go. All right, thanks so much for watching, everybody. Hope that made sense to you, and I'll see you guys next time.